Two. Cool, thank you. Okay, good morning. Yeah, some of you may know me as Major Malfunction, which is obviously my real name. Sometimes I go undercover as Adam Laurie. I do a lot of stuff on invisible stuff generally, so like Bluetooth, Wi-Fi, RFID now, and today I'm going to talk about RFID. Probably most of you saw Zach's excellent presentation yesterday on access control systems. I'm going to be talking about the front ends rather than the back ends, but we'll be looking at some of the same issues but from a completely different angle. You can see my stuff on trifinite.org and RFIDiot.org, which is where the RFID stuff is. Trifinite's mostly about Bluetooth. Anyway, we'll get on with that. So before we start, you guys, the previous speaker, John, talked about the DMCA to a certain extent, and we've now in the UK got some pretty dumb laws, and we've just updated our Computer Misuse Act, and now we've got this new clause which basically says if you produce a tool that is likely to be used in a computer crime, then you've broken the law. So, yeah. Which kind of makes life difficult for researchers, because until your tool starts to be used, you don't know what it's going to be used for. And if you think about it, if you applied that law to something like Nmap, then clearly when the guy first wrote Nmap and published it, there's a good chance that that would be used to look for vulnerabilities and to break the law. So it's now a very grey area as to where we stand as far as the law is concerned. Well, exactly. So the question is, does that include screwdriver manufacturers? So I sort of look at the parallel. Well, if we applied that kind of thinking to the physical world, where would we be? Now, I spend a lot of time sort of hanging out in hotels and stuff, and some of you may know that I tend to fiddle with the technology in the hotels. And I was at a hotel recently, and it was a brand new hotel, and it was sort of state of the art, and so I thought I'd have some interesting things to look at. And I decided to look at something physical rather than electronic, and see, if we applied those laws, how would that work in the physical world? And so the tools that I used are this multi-tool here. So obviously this is a dual-purpose tool and is therefore very evil and should be immediately made illegal. And these very, very dangerous objects. So the guy who came up with these has really obviously a very twisted mind and should be locked up, because these are very, very bad, which you'll see in a minute. So I made a little video of what I did, which I'm going to play for you. And normally I ask, actually when I give my talks on Bluetooth, there's three of us, and we take it in turns to who's going to be the lead speaker. And we had this kind of competition going to see who can get the most hands raised during a talk. And you couldn't just say, right, everyone raise your hands. You had to come up with an actual question. And so I thought of one which I thought might win me the competition. So for this one, I need to know, everyone raise your hands, anyone here has ever stayed in a hotel? Yay! I win, everyone in the room. Okay, so of those people, how many of you have ever used the hotel safe? Okay, about half of you. Okay. How many of those believe that it's secure? None of you. Oh, one of you. Okay. So why do you use it? Layered security for them. Yeah. Safer than handing it to the guy as you walk out in reception. Okay, so anyway, I made this little video of me playing with a hotel safe. And I showed it to a guy who was another speaker at a conference I was at, and he said, well, what would be really funny is if you get someone to read out the brochure for this hotel safe while you're doing what you're doing. So I asked for someone from the audience, preferably, someone female, sexy, got a good voice. Now, in this case, I don't need to ask because I already have a volunteer that meets all the criteria. So, Maggie, if you'll come up, please. So basically, she's going to read out the brochure while I play the video. I've deleted the name of the manufacturer to protect the criminally negligent. So if you want to take that microphone, or the podium, that's good.
Okay.
And when I tell you, I'll show you the video afterwards because you don't get to see it, which is, but I'll show you afterwards. Okay, so when I tell you, if you could read out, do you want to just test the microphones working?
Hi.
Is that good?
Okay. Is that better?
Yes.
Yay.
Okay, so let's try this. Okay, go for it.
Through the past 3 decades, we have developed the largest line of in-room hotel safes in the world, especially designed with the particular needs of the hospitality industry in mind. Our safes are available in a wide variety of dimensions and colors, with either electronic or mechanical locking systems. Safe Hospitality continuously researches the development of new features, functions, options, and designs for its products. From removable core locks to a variety of electronic systems with digital keypads, credit card readers, or chip cards, Safe Hospitality offers you products in the forefront technology. Our safes are installed in the most prestigious hotels and cruise lines throughout the world, which have recognized Safe Hospitality for its quality, warranty, and superb technical service.
Thank you. So, I mean, there's a serious side to that. In the physical world, we are getting, and in the security world in general, we're getting people pushing these products which clearly don't live up to their expectations. And they're getting away with it. I mean, this is not some crappy rundown hotel that I was in. This was a brand new hotel. This is a state-of-the-art safe. And they're able to just say, this is high security when it clearly isn't. Now, in the electronic world, we've got the situation where not only are they getting away with doing that, but it's now illegal for anyone to notice or to point it out to them. So, I think that's bad, and we should try and really push to change that and to challenge that. So, any effort to fight the DMCA or in the UK the Police and Justice Act should be followed up vigorously, really. Okay, so the reason we're actually here is to talk about RFID. So, as Zach explained yesterday, is there any chance you could actually point that light or kill it or something? As it's right in my face. They're mostly passive chips. Okay, well that's fine then. I'm happy. Can you turn it up a bit? Okay, so we're mostly talking about passive devices. There are active ones which have batteries and stuff, but the ones I've looked at so far are passive. Now, I'm not going to go into too much detail about how they work electronically, but I am going to talk about how they work at the kind of protocol level and the logical level. Some of you may have noticed the title of my talk. It was called Hacking RFID Without Soldering Iron, or a Patent Attorney. Now, there was a case recently for a company who shall remain nameless, who prevented a talk being presented at Black Hat. And again, it's what we're talking about, the not being allowed to talk about insecurities. Basically, they threatened to sue the company who were going to present under patent laws because what they were doing was cloning their devices and replaying them, and by doing so they had created a device that used their patented algorithm and therefore had breached their patent. And so rather than addressing the problem, they throw their patent attorneys at it and say, right, well, that's it, problem solved. You can't do this because it would be breaching our patent, so everyone's happy. So we'll talk a bit about their stuff as well. So the two kinds of use that these tags get generally used for is the ID-only type things, which we'll talk about in some detail, and then the more advanced ones, the smart cards, where you're actually having a conversation with the chip. And again, we'll talk about those in more detail. So the ID-only stuff, the kind of things that's used for, animal IDs is probably the oldest tags, ear tags that tell you which number this cow is. Some hotels are now using them as door entry keys, car immobilizers, and sort of one-off ski passes, stuff like that. Luggage handling. Has anyone been through Tokyo Airport recently? Yeah? You probably find if you look on your bag, you've got an RFID tag stuck to the bag because they have automated systems for directing the luggage.
If you're at the airport looking at the carousel, this is international, you see the tags quite clearly. They look like an H shape.
Okay. Okay, so apparently the tags look like an H, and the chip's in the middle, and the legs are the antenna. So they're quite easy to spot. And human implants, which is a kind of scary thing, which again we're going to talk about in more detail. So I came across this cartoon to do with human implants, which I thought was quite amusing. I think you'd have to put a hell of a lot more than a camera and an MP3 player in it to get me to bend over to have one of these installed, but I just thought that was kind of a funny take on it. So these two rather nervous-looking gentlemen are about to have an implant done, or in fact, I think he's just had one. So this guy on the top is a journalist, and he's visiting a beach, I think it's in Spain, where they've signed up to this program where all the beach vendors accept an RFID chip as a kind of digital wallet. And so you can buy drinks, and you can rent deck chairs, and you can go into clubs and stuff like that by just having your thing scanned. And it's kind of a good idea. It means you don't have to take your wallet to the beach where it might be stolen. You can leave it in your hotel safe instead, where it'll be perfectly safe. The other guy, he's from the Mexican government, and they're actually using this for access control. So basically, he can get into parts of the building that other people can't because he has a chip implanted that lets the reader know he's there. And in the UK, they talked about putting it in mental patients. I think there's, you have a completely gaga patient that walks out of a hospital, you can scan him and see who he is and send him back to the right ward. And I think there's quite a lot of it here being pushed by a company that are promoting it for medical uses. So I think they're pushing it more on the basis that if you have an accident, you can be identified and they can figure out what your blood type is and all that kind of stuff. So. Now the whole basis of all this technology is that you've got a unique ID. Okay, it's absolutely guaranteed that ID cannot be cloned. You go to the manufacturer's websites and they will say, that we've got patented algorithms. It's not possible to produce two units with the same ID. So I don't know if any of you were at DEF CON last year. A guy called Jonathan West who's presented a device which basically clones tags. So and you can download the source code and the schematics for the device. It's about $20 worth of bits. You can build that and it will clone pretty much any RFID tag. So of course, when that happens, the industry comes along and comes out with a defense why this isn't a problem. And I sort of like to think about the scene where the techie comes back from the conference and he goes to his management and says, "Oh my God, they're cloning our tags. Game over. Anyone can clone a tag and walk through the door." And the executives are like, "Okay, well, run along, little techie. We'll think about this. We'll come up with a solution." So, thank God for the executives because they came up with the perfect solution. So, it doesn't look like the original. What's your problem? Anyone can see that's not that. So, run along, no problem here. So basically, that was their defense. It's not really a clone because it doesn't look like the original. So we don't have to worry about the problem anymore. So we got into an argument about semantics rather than, dealing with the actual technical issue. But obviously, we understand that the reader doesn't physically look at the device. It just reads the tag, and if it gets the same ID, then it's effectively the same device. So as far as the reader's concerned, that equals that. Now, when I started researching this talk, I had a look. Jonathan Westhus's device is there, but there are also if you search on the net, there are a bunch of different projects where they've done similar stuff. And, these are all fairly easy to find projects. And in fact, this last one is a Circuit City, do your own cloning device over the weekend project. So, but not to worry, none of them look like a tag. So we're all perfectly safe. This isn't an issue. So I took that as a challenge. Could we actually get past the semantics argument and really look at this and see if there really is an issue here? And to do that, we have to create a true clone. So one that not only has the same digital number, digital identity, but physically the same form factor. Okay, so to do that, first we have to understand how the ID is presented and how it's structured and so on. So I took the example of animal tagging. Now this is a standard called ISO 11784 or FDXB, and basically it has three fields. You get an ID and it consists of three parts. The first part is a flag which just says if it's an animal application or a non-animal application. Then you get a 3-digit country or manufacturer code, and then you get your local unique ID. So the country or the manufacturer will issue the national ID. And the way that's actually transmitted from the tag to the reader is you design it to work on a particular frequency. So most of these ID-only tags actually work in the 125 kilohertz range. The smart cards tend to work in 1356 megahertz. You will transmit the data at a certain bit rate, which tends to be frequency divided by some factor of 2. You'll send it with a particular encoding mechanism, so whether it's FSK or Manchester or biphase or whatever. And then you send a specific bit pattern. So some of these parameters are in common between the different standards. So they have a header or a bit pattern structure that allows them to identify themselves as being tag type A instead of tag type B, even though the rest of the parameters may be the same. So if I was to take an animal ID and read it on a dumb reader, what I would get is an 8-byte sequence of numbers. And if you look at the structure here, so the first few bytes are the national ID, then you've got the country, and then you've got the application code. And you have to perform a few operations on that number to actually translate it to the real IDs. So basically you take the raw ID, you reverse it, reverse the bits, you then reverse each nibble, you then write shift the country code, and that gives you the decimal code, which you can then look up. There's a website on icar.org. icar is the organization that control the manufacturer's IDs. You can go and look that up. And so in this case, ID 985 equates to Destron Fearing, and they've issued the local ID of 312, blah, blah, blah. So that's quite simple. And this is all published, so you can download the specs and you can read how that works in more detail. So if I want to encode the ID, obviously I just reverse that whole process. I create my 64-bit raw ID. I then have to add the binary headers. So I stick a header on. The fixed bits in between the ID bytes is basically, the headers are a bunch of zeros. So it's like a 1 and 9 zeros or something. And so what they do then is they break up the ID into 4-bit chunks, and they stick a 1 every 4 bits. And what that does is it prevents the header from being accidentally repeated in the bit stream. So the 9 zeros can't exist in the data because there's a 1 every 4 bits. So we now have our raw 128 bits of data. So how do we actually deliver that to the reader? Well, I thought about this from the manufacturer's point of view. If I was a manufacturer making RFID chips and there's this huge explosion of use and proliferation of different standards, I wouldn't want to be making from scratch every different type of RFID tag. So it seemed to me that what they would do is they would produce a tag that was able to be switched between the different formats. because that makes their life much easier, lower manufacturing costs, stocking costs, and so on. So I looked around the market, and sure enough, I came across a couple of tags that actually follow this philosophy. So there's a device called a Q5, and what the Q5 does is it allows you to set each of the parameters independently. So you can take, you can set the bit rate, you can set the modulation. You've got 224 bits of user programmable data. I need to program 128, so that's plenty of room for me to put my ID in. And you can tell it how many bytes to actually spit out when it gets woken up. So these are dumb tags. They sit there, and when they get energized, they start barfing the bit pattern out. So you tell it how many bits of the 224 to actually spit out. The other approach is there's a device called a HiTag2, and that's similar in that you can program it to tell it to use different parameters, but it has already pre-programmed personalities. So it has 3 different modes of operation, and they translate to a certain bit rate, modulation, and so on. So, and those 3 modes actually, as it happens, equate to the most commonly used ID or door entry systems, car immobilizers, and animal tags. So quite handy, the 3 things that we might find interesting, shall we say. Okay, so I now know that this stuff exists and I know how to produce the data. So I started looking around at, where can I get one of these? And I had an office, we have a door entry system at my office. So I had a look at that, and we actually moved office, so it was now redundant. And I found that I could actually reprogram my existing door tag. So if I just set the bit rate, set the modulation, program the ID into it, it should then behave like the thing I'm trying to emulate. Okay. So I'm going to give you a quick demonstration of an access control system. It's not as pretty as Zach's. It's actually a bit of gaffer tape and a battery and an LED rather than a nice unit. But and actually this raises an interesting issue, because obviously I flew here. Right? How many people flew here? A few of you. I can't see you anymore because I'm busy looking good in the lights. So I flew here, and I have a lot of stuff in my bag which could be misinterpreted. So you've got. So I tend to carry it in my hand luggage so I can explain when the officers want to know why I've got things with batteries and circuit boards and so on. So I was coming through the security checkpoint, and in front of me there was a couple with a newborn baby. Okay, so they've got their pram and they've got their baby and they've got a bunch of luggage, and they're scanning it all through the machine, and the wife gets sent through, and the baby gets sent through, and the pram gets sent through, and finally the guy's left on his own with a sort of little zippy bag thing, and inside the bag there's 6 bottles of milk. Okay, and the customs, the security guy says, well, you can't take liquids on board. And he's like, okay, well, we've got a 12-hour flight, we've got a newborn baby, this is his milk, needs to go through. So he calls his supervisor over, and the supervisor says, okay, no, that's fine, milk's an exception, baby milk's an exception, you can take that through, but you have to prove that it's milk first. So he has to take the lid off each bottle and taste each one. And first of all, I'm standing there thinking, what kind of milk is that? You really love your wife, don't you? So anyway. So he tastes each bottle and he sends it through. And by this point, there's, this is all taking time, and there's a bit of a crowd building up behind us. And there's, 2 or 3 security guys. The guy from the machines come over, and they're all kind of milling around. And I'm thinking, great, that's all I need. I've got a bag full of electronic crap, and there's, bits and pieces that they're going to have to really look at if they want me to pull it out. And it's all up on the screen, and there's circuits, and there's wires, and there's batteries, and there's all sorts of crap. And I've now got these 3 guys all standing there and a big crowd of people behind me. So they're looking at it, and they're looking at it, and sort of nudging each other and talking. And then one of them turns to me and says, there's no fluids in there, are there? No, fine, on you go. That's good. So, it's crazy. What's happening at the moment is people are focused on shoes and fluids and anything else, just because it looks like a bomb, that's fine. Don't even bother checking what it is. It's not fluid. So, a bit crazy. Anyway, so if I plug this in, so what we've got here is an access control system. This is the reader. This LED lights up if I open the door successfully. So if I take the correct door tag, hopefully you'll see. Can you see the LED? Okay. So basically that would be the door actuator that opens the door. If I take my door tag, nothing's going to happen, okay, because it's the wrong door tag. So what I'll do now is try and reprogram this to be that. How's that? Is that readable? Okay, so what I'm going to use is an off-the-shelf compact flash format reader-writer. And this is a little keyboard wedge reader. So basically, these tags are sold under the brand Unique, okay? And you can buy a Unique reader, and this is a keyboard wedge, which if you put one of these on it, it will just type it into the system as if you'd typed the ID on the keyboard. So if I put that in, should get. So basically just presenting the tag to the reader gives me its ID number, okay? So as this is branded Unique, I've written a little program called Unique. And I tell it it's a unique tag, that's its ID, and I want to write it. So I take my blank tag, and in theory that's now done. So that's been reprogrammed to be that ID. So if I got it right, what should happen if I hold it up? So I'm now in your building. So as you saw, the kit to read the ID is simply that. So if I had that in a little handheld and I walked past you, read the key out of your pocket, that's all it took, a couple of seconds to get that ID, and I've now cloned your door entry system. So, I'm sorry, say again? Did I use the same device to write it? No, this is a read-only device. They're pretty cheap. It just reads the ID number. This was the one I used to write it, which is a compact flash writer. I'll talk about the hardware towards the end, but this stuff is freely available, and it's not cheap, but it's not hugely expensive. Do ask questions as we go along, by the way. Okay, so that's the ID systems. The other thing I was going to talk about was cloning an animal tag. So normally I would bring my cow along, but she got detained at security. Something to do with fluids. I don't know. But, so I have with me my little mouse friend, who actually, if anyone's interested, if you want to get implanted, this is the needle that they're going to stick in you. Okay. So he squeaked a bit when I put it in him, but not too much. Do you want to pass that around? Oh, sorry about that. You're now permanently tagged, but never mind. Okay, so basically, normally what I do is I have a little webcam so I can show you what's being shown on the display, but I cleverly did an update and broke my drivers, so it's not actually working this morning. So what I'll do is I'll just pass this around, and basically you press the red button and it will start scanning, and then when you hear a beep, it's read the ID. So it's read off 968 0000 470 8897. So I'll just pass this around and you can start having a look at it. So the idea is I'm going to try and reprogram this tag so it's now a completely different standard. The original standard that I've programmed it to be is unique. I'm now going to program it to be an FDXB tag and try and be the same ID as the mouse. Okay. So first thing I have to do is reset the tag back to its original state. When I first started doing this, this was the only tag I had, and I quickly broke it, obviously. When you're experimenting and you're messing around with header formats and so on, it's very easy to send it the wrong thing and the tag just decides it's not going to play anymore. And I then found a manufacturer who sold blanks, so I bought a pile of blanks, and after a while I broke all of those too. So one day I was on a very long train ride and I was going to a job and I had like 4 hours to kill. So I sat down and thought, I need to fix this. So I actually came up with a program. These are the Q5 tags. So I came up with a program that fixes that. So that resets it back to a default value, and I can then program it. So I tell it it's an animal tag. I then give it its local ID. So whoever's got the reader, if you could shout out the number.
968 5 zeros.
Yeah.
470 8897.
Okay, so again, I tell it I want to write the tag. Actually, in the interest of trying to follow the original form factor, what I'm going to do, instead of writing it to this, I've got one of these tags in my wrist. So I'm going to reprogram my tag to be the mouse. Okay, so I will do that. Never do live demos. Okay. So in theory, that's now reprogrammed. So whoever's got the scanner.
Is that in your watch or your wrist?
Okay. I'm not crazy enough to have one of those needles stuck in me. It's actually sewn into my watch strap. So if you want to scan the mouse first, press the button. Okay, and read the ID.
It's 968 5047 8897.
Okay, so now scan my wrist.
968 5047 8897.
So, if you want to carry on. I am that mouse.
Congratulations, you're now a mouse.
Thank you. Yeah. My wife will be delighted. So, unique ID, I don't think so. Does it only work across the same chip type or form factor? The Q5 device is sold in dozens of different form factors. So you can get it from these kind of cards, credit card shaped cards, key fobs, ones that look like this. You can get ones that are impervious to heat, little nails that you can nail into wooden planks, all kinds of formats. So whatever it is you're trying to clone, there's a very good chance you'll find the physical format that matches the original. So some of the issues I thought about, why this is a problem. Obviously, you can track individuals. I'm using a little reader like this. But if you've ever been in a shop, and you see the security gates as you walk out, those two gates that catch you shoplifting, those are basically using the same technology. So you could position those around the place, and anyone who walks through them, you'll read their IDs. Or you could wire wrap a door. Anyone that walks through the door frame, you'll get them, hide an antenna under the floor, whatever. So the potential to track people. Which means you can then obviously target individuals if you're looking for a certain person arriving on the scene. Impersonate people to get access to buildings, but also the other way around, provide an alibi. If we start using these for compliance, so say somebody's on probation and they have a tag implanted and they have to go to a police station once a week or once a day and prove that they are there. If I reprogram my tag to be them, then I've provided them with a perfect alibi. I've got the police saying, yeah, he was here in the police station at 11 o'clock when that bank was being robbed. So, and obviously the sort of far end of the scale, we all like to talk about the T word. Smart bombs go off when a certain person comes in range. I've heard that there's a South American military are actually using these implanted tags for their officers, so the officers get access to certain parts of the base and the grunts don't. So you see one of these implants going by, it's an officer, time to go bang. So how do we fix that? Don't rely on raw IDs. Okay, so we're now going to talk about the smart card type RFID tags that actually you have a conversation with the tag. And the example that I'm going to use is the UK passport, or the e-passports in general. Now, I quite often get asked, how do I know if my passport has a chip in it? This logo here, that's an international standard. If you've got a new passport and you have that logo on it, then you have a chip in your passport. If you don't, then you probably don't have a chip in your passport. But that's the clue. If you come from the UK, the other clue is there's this dirty great chip in the back of your passport. But I don't know why we do that, but most countries don't. The chip is hidden. So what they're actually doing with this stuff is they're storing data about you on the passport. If you go and look at the standard, there's defined in the standard 48 different fields of data that they're going to store on these passports. And that includes stuff like, biometrics, fingerprints, your facial image, so the picture that's in the passport, the document you used to get the passport in the first place. So if you produced a birth certificate, that will be scanned and stored on the passport. Your home address, your phone number, your profession, all kinds of stuff. So really, an ID thief's paradise. So it's got all this really secure stuff on it, or important data. So obviously you want to protect it, right? So they use encryption. They use pseudo-random IDs. So unlike this tag, when you present the passport to a reader, this tag gives off a unique ID. With a passport, it gives off a pseudo-random ID. So I can't just walk past you and find out your passport number is 1234, and I can now track you, because next time I scan your passport, it's going to give out a completely different number. To read the data from the passport, I need to authenticate. So they've encrypted the communication between the passport and the reader, and they've done that with 3 days, and that's a standard called Basic Access Control. Now, the standard says you don't have to protect it. You can allow people to just log in and read it without doing any kind of authentication. But if you do, then you have to use the Basic Access Control standard, and that's all laid out exactly how it works. The other thing potentially you can do is encrypt the content. But again, that's optional. It's up to each country whether they do the encryption or not. And if they do, in this case, it's also up to them how they do it. Did you have a question?
Yeah.
Okay, so the question was, because 3DES is a symmetric key algorithm, how do you've either got one key that's shared by everyone, or you've got some massive key management problem, okay, or you have to do some kind of key exchange. So you do, well, what you do is actually you do some hashed challenge responses. So yes, good point. So what they've done is they've standardized the way you figure out the key. It's different for each passport, but the way you find it is the same. Okay? So basically, you read the MRZ, the machine readable zone at the bottom of the passport. You take the first field, which is the passport number. You take the date of birth, and you take the expiry date of the passport, and you add those things together, and that's your key. That's very secure. So I'm actually going to demonstrate doing this. So change reader. Again, this is an off-the-shelf reader. This is the high-frequency stuff. So quick change of kit. I also need to... Okay, so normally what would happen is you would hand your passport to the border control, and they would take it. They'd run it through a machine called an MRZ reader, and that would read the bottom line of the MRZ and derive the key from it. Because I don't have an MRZ reader, we have to type it in. So here's one I prepared earlier. So if I put the passport there. So it's now read, it's logged in, it's now reading the files. As you can see, it's read the MRZ data, so that's the actual name and the date of birth and stuff stored in the passport. It's now reading another file. Each item is stored as a discrete file. So there is what is actually stored. So as you can see, I was much better looking when I had this passport, even with the lights and all that. This is actually my son's passport, and this is what's stored. So none of this is taken off my hard disk. This is actually stored in the passport. So his image, name, date of birth, expiry date, all of that stuff is directly stored on the passport. Okay. So if you now wanted to make a duplicate of this passport, you've got not just a rough idea of what should be on there, but the exact data that should be on the real passport. Yeah. Which I can't help feeling is bad. Plus whatever data they use to get the passport. Actually, at the moment, this is all that's stored on there. I haven't seen, I've looked at probably 6 or 7 different countries' passports, and so far the only thing I've seen stored is this stuff. The newer stuff, like the fingerprints and so on, isn't yet stored on any passports. But in the UK, by 2010, you'll have to actually, in order to get a passport, you will have to be fingerprinted and iris scanned and a whole bunch of other stuff. You're going to have to give up those 48 items of data. The other thing, sorry, go on. Okay, how difficult is it practically for somebody to clone your passport because they have to actually get hold of it? Thank you. Well, there's 2 answers to that. One is, once you've got it, the blanks are available. It has been done. A German researcher, whose name escapes me just at the moment, but I can find out if you're interested afterwards, has already proved that you can just take this data and copy it directly to a blank. The blanks are worth about £1 each. Maybe a little bit more. So it's definitely doable. one of the defences, I mean, I've been having some discussions with the UK Home Office about this stuff, not directly, through the newspapers, of course. So I do stuff, they publish a story, they issue a rebuttal, and so on. But one of the things they said was, okay, so you've copied a passport which you had in your hand and you could have photocopied. What's the big deal? And so I was challenged by a UK newspaper called the Daily Mail to say, well, would it be possible to read the passport without actually having it open in your hands and being able to read the MRZ? And I believed it was, and so they challenged me to actually do that. So the way it worked was I went to their office and they had someone apply for a new passport, and it arrived, and in the sealed envelope, they gave me the sealed envelope and said, right, now read that passport. And I read it in about 4 hours, basically. So I brute forced, yes?
Is there shielding material in the UK passport?
There's no shielding in the UK passport. The only passport I've seen so far that has any shielding in the cover is the US passport. So if that had been a US passport in a sealed envelope, I wouldn't have been able to read it. The UK passport, when it's closed, you can read it. But incidentally, the US passport, if you just allow it to flop open like this, the shielding actually acts as a kind of amplifier and makes it even easier to read. So. But the reason that was possible, so if I try and read this guy again, say I didn't know the last 3 digits of the passport number, I can just brute force it. There's no protection in the passport to stop me just doing repeated access attempts and failing and trying again. Yes, sir? Right, so the question was, now I did it once, would it take 4 hours to do the next one? No, it would be considerably faster, because the key space I was having to check included what I thought was roughly the current passport number. Because we issue the passport sequentially, I knew roughly where they were, and what I was doing was checking about 10,000 numbers. Once I've done one on a particular day, I would have a much better clue as to where we were in the sequence, so I'd probably only have to check about 1,000. So it would be about 10 times faster. This is just for new ones, yeah. So I mean, this is not a practical attack against random passports you see in the street. But the point was that, you know, the defence that it was impossible to read a passport without having it physically in your hands and open was failed, was not true. So, any other questions?
Okay, so you can copy one. Can you forge one?
Okay. So the question is, so you can copy one, but can you forge one? So can you change the content of an existing passport, or create a completely arbitrary one? So when I was reading the files, as I said, each one is stored in a discrete file. So each object, each of the 48 items is in a file stored on the passport. So the image is in a file called EFDG2, and I extract that to a JPEG. There is a file called the security object, EFSOD. And EFSOD contains digital signatures for each of the other files and a signature for itself. If we look at that with a hex editor, you can see that within there's the signing authority's public key. Okay, so you can check the signature against the public key of the authority that issued it, which you read from the passport. Anyone spot the deliberate mistake? Okay, so basically you're checking the validity of an object stored on this object against an object stored on this object. So I give you the new key that matches the signed stuff that I've given you, and it's game over. I'm sorry, at the border they? Yeah, so, okay, the defense against that is at the border they would have the public keys that they're going to check against. you've got something like 28 countries signed up to this. These keys are going to expire monthly, I believe. So you're going to have a massive key distribution problem, CRLs and so on, which we know anyone who does PKI will know that the CRL issue is one of the biggest issues you have to deal with. So again, I brought this up in the UK and said, well, it's not secure because I could forge the key. And they said, oh no, there's a thing called the PKD. So the PKD is the public key directory, and it's an internet accessible directory of all the public keys and all the revocation lists for all the countries signed up to this project. So I read the specs, and sure enough, the spec says there is a PKD and it will be publicly accessible over the internet, and here's how you talk to it, blah, blah, blah. So I contact the UK Passport Office and say, how do I get access to this? No response. I'll search the internet for any clues as to how you get access. There aren't any. So I found the website of the working group that are actually defining the standard for the PKD. They finally ratified their design, I think in June of last year, and they put it out to tender at that point, and I believe they appointed a company to deliver this system in around October of last year. So if this system is already deployed and working and being used, that will be the fastest government IT project ever done in the entire history of the world. I just don't believe it exists at the moment.
Are these public keys signed by a certificate authority?
Yes, so the question is, are they signed by a certificate authority? This is the public key of the certificate authority. So the way the PKD works is each country sets up its own authority, and they have right access to the PKD, so they can update the public keys for their country. So it's up to you, the person checking the document, to go and get the public key and check that it matches the one on the passport and that the signatures match for the objects that are signed with that key. Any other questions? Yeah.
In your discussions with the government, did you run into any things dealing with the RFID disabling, i.e. just beating the chip with a hammer, and then therefore being held criminal against altering a government document possibly?
Right, okay. Okay, so the question was, have I had any discussions with them about disabling the chip, or what would be the response if I try and use a device with the chip disabled? The standard specifically says having a non-functional chip should not prevent you from crossing a border. Okay, so the device isn't expected to necessarily work, and in fact, in a recent audit office review of the technology in the UK, like most countries, our passports last for 10 years. The chips are warranted by the manufacturer for 2 years. So I think it's not a problem if it doesn't work, but if it didn't work the second time, they'd probably make you pay. So the first time they'd say, you need a new passport, we'll replace it. Second time they'd probably make you pay, and the third time they might detect some kind of pattern forming here and decide to prosecute you, because this isn't mine, this belongs to my son, but mine belongs to the government as well. So I'm not allowed to interfere with it. Right, so you don't bother replicating one with a chip, you just do a blank one which doesn't have the logo on or whatever. That's not going to work because, for example, in the US, if I have a passport, as a UK citizen, if I have a passport issued after October of last year and it doesn't have an RFID chip in it, then I cannot participate in the visa waiver program. So the US has actually forced this technology onto the rest of the community by imposing that restriction. So everybody had to adopt e-passports by October of last year, otherwise their citizens couldn't travel freely to the US anymore. So. Well, as I said, if you have an RFID passport and the chip's not working, you'll get away with it the first time. Yes, you could, and you'd get away with it once. So you can either disable your existing chip or you can forge your own and not have a chip in it at all, but the end result will be the same. That they will probably let you through the border once, and the second time they will start to ask awkward questions.
So the terrorists will get through?
Terrorists will get through once, which is all they need. So. Yes, sir. Okay, so from the point of view of identity theft, could you just walk past someone and read their passport? Answer no, because you need to know the key details. So in order to log in, I need to know quite a lot about the passport to be able to do the 3DES basic authentication. So it's not really a threat as far as sort of drive-by attacks go. But the real issue, I think, from my point of view, is when they first introduced these, they said this is going to increase your security. I can't see anything about having that chip in there containing digital copies of my data that does anything to enhance my security. This is not a better, more secure passport than the old one that didn't have a chip in it.
But somebody can read the chip now, then they can offline look for the identity. And what the entropy is not very high.
You can't. Okay, so the comment was you could read the chip and then offline brute force the ID. No, but the mechanism is it's a challenge response. So you say to the passport, here's a random number hashed with my key, and it says back, go away. That's the wrong number. So, yes, sir.
If you're sitting next to a person in an airplane for 10 hours.
If you're sitting next to someone in an airplane for 10 hours, you could brute force it, yes. And in fact, I've got a little Bluetooth reader that allows me to plonk the reader somewhere and sit somewhere else doing the actual work. So I think we're running out of time, so I'll just quickly flash through my final slides. The obvious threats, we proved that we can get the key data from other channels. We don't physically need the passport in our hand. I've also found I can profile passports to a certain degree, so I can tell when I see a passport, even without logging into it or trying to read the details. So just random person walking past, I can figure out to some degree which country you come from for certain countries. So I reckon at the moment I can determine a US passport, I can determine an Italian passport, and I can determine an Australian passport. So the code that I've been using here is all open source. You can download it. It's currently drives a couple of different manufacturers' devices, ACG and Frosch. There's an open source project called OpenPCD, which we're about to start work on, trying to get my code working with their hardware, so you can build your own very low-cost reader. I actually have a few bits of kit with me if anyone's interested, but I build these things. ACG don't normally sell to end users. They don't have any kind of finished products that you can just buy from their sites. So I buy the components and I solder them together and I sell them. It's not something I particularly want to do, so if anyone finds people who are shipping ready-made readers that happen to be ACG under the hood, let me know and I'll point to them on the website. This was the comment from ACG. Having been very helpful at the beginning, they suddenly noticed what I was doing. Which I think is a kind of a shame, because it's in all of our interest that the technology is secure. But it's kind of typical of commercial industries looking at people pointing out mistakes. And that's pretty much it. Any other questions?
Do you think the reprogrammable cards are going to go away then? Or?
Do I think the reprogrammable cards will go away? No, I really don't think so. I think the problem is just the way they're being used. You shouldn't rely. An RFID tag is it's not an authentication token, it's an ID token. So you shouldn't rely on a unique number to say not only is this what it says it is, but it's guaranteed to be, being operated by the person who's authorized to use it. You have to have some second factor of authentication. So.
One question I had that may or may not have been already addressed. When you're talking about earlier about
if I've understood you, could you block people from being able to read your tag by broadcasting another tag? Is that what you're saying? Yes. On the low frequency stuff, there tends to be no collision detect. So if you put two tags in the field, it's not going to work. The higher frequency stuff, the ACG, the 1356 smart card stuff, they do kind of random back-offs and stuff to allow multiple tags to speak at the same time. Okay, I've definitely overrun now, but before we go, I just wanted to quickly mention there's, as you've probably seen, there's some collections going on for the Hacker Foundation, and one of them is to pay to see a grown man sacrifice his colon, which I think is a task that we would all like to contribute to. And I know some of you may be worrying, he's flying home tomorrow and there'll be other passengers on the plane, and we maybe have to think about them, but in any good cause there will always be some collateral damage, so I think that's a risk that we should take. So everyone, please reach in your pocket and put $10 or $20 into there, and we will see this man eat 40, what is it? Is it 40? A 40 patty In-N-Out burger in one sitting, which is a really horrible sight, but anyway, there you go. Anyway, thank you. Oh, again, well, can you thank Video Man for helping Zach with his...
And thanks to Video Man, wherever he's at, for helping Zach out with that demo last night.
Your job sort of requires some degree of oversight.
Right.
But it does seem
but we're going to break for lunch. Want to let everybody know some folks had asked last night about the badges. And if we had any that didn't have the grommets in them, we could use them in their original purpose. We have a bunch. Want to pick them up. We're getting rid of them.